So we're going to start off this lecture by looking at two key definitions. We're going to think about the difference between mass and weight. Now, quite simply, mass is just the amount of stuff or matter that is in an object, and it's measured in kilograms. The only way that can change is if the object itself changes. But the weight is something different. The weight is actually a force, and that is the measure of the pull of gravity on a particular object, and that's measured in newtons. Now, the weight can change if either the mass itself changes or if the strength of gravity changes, and we're going to think about how that might happen. If we were to compare the Earth and the Moon, the Earth has a much greater mass than the Moon, so it has a much stronger force of gravity. In fact, the Earth will pull on every 1 kilogram of mass with a force of 9.81 newtons. So we often round this to 10, so we'll do that. They will do in your exams. So we can say that the Earth has a gravitational field strength of 10 newtons per kilogram. It'll pull on every 1 kilogram with a force of 10 newtons. The Moon has much less mass and a much weaker gravitational field, so it would only pull on each kilogram of mass with a force of 1.6 newtons. So it has a gravitational field strength of 1.6 newtons per kilogram. So we're going to look now at the equation that links the weight of an object, its mass, and the gravitational field strength. We can see that the three terms are linked as follows. The weight of an object equals its mass multiplied by the gravitational field strength. Remember, on Earth it's 10 and on the Moon it's 1.6. So we've got another formula triangle to learn here, where the W stands for weight, G is the field strength of gravity, and M is the mass in kilograms. So we're going to try an example question. So we're going to look at a weightlifter. So an Olympic athlete lifts 200 kilograms above his head. We're going to calculate what it weighs on Earth, and we're going to calculate what it would weigh on the Moon. The formula for the calculation is going to be the same in both occasions. Remember, cover up the one that you don't want. So we are calculating the weight, so we cover that up, and we could see that it'd be M times G. So on Earth, we can see the weight equals mass times gravity, which equals 200 times 10, which would equal 2,000, and remember weight is a force, newtons. Whereas on the Moon, we still have a 200 kilogram mass, but this time the gravitational field strength is 1.6, so it would only in fact weigh 320 newtons on Earth. Now, there's the same amount of matter in the bar, there's 200 kilos on both, but the force of gravity pulling on the object is weaker on the Moon, so the weight itself is lower. So you've always got to remind yourself of the difference between the two terms. The mass is the amount of matter or stuff as an object, and the weight is the measure of the pull of gravity on an object. It's a force, therefore it has a vector quantity. It has a direction which is always towards the centre of the gravitational pull, and it has a magnitude which we just calculated there.